Good morning, third grade. Our target for today is I can represent repeated addition story problems using pictures and graphs. We've learned about three multiplication story problem types so far. Area multiplication is where you are finding the total square units covered by an object. You're finding the total area that an object covers. To solve an area multiplication story problem, you multiply the length of the rectangular object times the width of the rectangular object. Array multiplication is different than area multiplication. In an array multiplication problem, there are physical items that are arranged into rows and columns. You're trying to find the total number of physical items. To solve an array multiplication problem, you multiply how many items are in each row times how many rows there are. Most recently, you have learned about equal-sized group multiplication. In an equal-sized group multiplication problem, physical items are organized into equal-sized groups, and you're trying to find the total number of physical items. To solve an equal-sized group multiplication problem, you multiply the number of containers times the number of physical items that are in each container or in each equal-sized group. Today we're going to be learning about our fourth and final multiplication story problem type. This story problem type is called repeated addition. Repeated addition means adding the same number multiple or more than one times. For example, 2 plus 2 plus 2 plus 2. We're adding the same number 2 multiple or more than one time. We're adding it 4 times in this problem. A quicker way, third grade, to solve repeated addition is by multiplying. Instead of adding 2 plus 2 plus 2 plus 2, I could multiply the number that is added repeatedly, 2, times how many times you added it, 4. 2 times 4 equals 8. This was a quicker way of solving 2 plus 2 plus 2 plus 2. I used multiplication to solve this repeated addition problem. A repeated addition story problem is a problem where the same action happens again and again the same way. For example, Miss Glassy drinks 4 bottles of water every day for 3 days. Repeated addition story problems, like we said, have the same action happening again and again the same way. In this example problem, drinking 4 bottles of water every day is the action that's happening again and again the same way. The action is drinking water, and it's happening the same way, 4 bottles each day. In repeated addition story problems, the repeated action often occurs over time, like days, hours, weeks, minutes. In this example, Miss Glass is drinking 4 bottles of water every day for 3 days. So it's occurring over time. It's occurring for 3 days. Repeated addition problems happen often in everyday life. Remember, it's only repeated addition if the action is the exact same every single time. Let's go ahead and look at a real example we might see in our lives. Noelle buys 2 teddy bears each month for 4 months. Here you can see Noelle bought 2 teddy bears the first month, and 2 more teddy bears the next month, and 2 more teddy bears the third month, and 2 more teddy bears again the fourth month. For 4 months, she's buying the same number of teddy bears, 2. In this repeated addition problem, of course, there's an action that's happening the same way every time, buying 2 teddy bears. There's also a time, or how often it happens. Well, she does it for 4 months. We represent repeated addition story problems using a number line. This is what the number line would look like to represent this problem about Noelle buying 2 teddy bears each month for 4 months. You can see that I have shown how many months she did this for, 4 months, and you can see every single month, starting at 0 months and going all the way to 4 months. You can also see that I've shown the action, buying teddy bears, and you can see that each month she buys 2 more, so I add 2 more teddy bears. Plus 2, plus 2, plus 2, plus 2. Each month, she's repeatedly adding the same number of teddy bears. She's getting 2 more when she buys 2 more. You can also see the total number of teddy bears she has as time goes on. After 0 months, she has 0 teddy bears. After 1 month, she has 2 teddy bears. After 2 months, she has 4 teddy bears. After 3 months, she has 6 teddy bears. And finally, after 4 months, she has 8 total teddy bears. We always represent repeated addition problems using number lines like this, where we can see both the time or how often it's happening and the action. Let's go ahead and look at another real-life repeated addition problem. Elijah runs 5 laps around the track each day, Monday, Tuesday, and Wednesday. Well, right away you notice that there is a repeated action happening again and again and again, and also that there are some days, Monday, Tuesday, and Wednesday. I know that I would represent this problem on a number line. So let's see here. So I can clearly see that the action in this problem that's happening repeatedly is that Elijah is running 5 laps around the track each day. The time, or how often it's happening, is a little bit trickier to figure out because it doesn't tell me he does it for how many days he does it for. It doesn't say 2 days or 6 days. It says Monday, Tuesday, and Wednesday. Thankfully, I'm a mathematician, and if I think about that, I see that Monday is 1 day, Tuesday is a 2nd day, and Wednesday is a 3rd day. So when they say Monday, Tuesday, and Wednesday, that's really the same as saying 3 days. So how often he does it, or the amount of time he spends running laps, would be 3 days, Monday, Tuesday, and Wednesday. I'm going to go ahead and represent this problem. Elijah runs 5 laps around the track each day on Monday, Tuesday, and Wednesday on my number line. I'll start with the time, or how often it happened. In this problem, the time is days. Monday's a day, Tuesday's a day, Wednesday's a day. So my time is days. Think with me here for a moment about what the action is in this story problem. Elijah runs 5 laps around the track each day, Monday, Tuesday, and Wednesday. Well, the action that Elijah's doing is he runs laps. And how often is he running the laps? Oh, that's right, he's running them each day. So my time, or how often it's happening, is days. Once we're ready to start making our number line, we're always going to start with the time, or with how often it's happening. How many days did Elijah spend running laps? Well, Monday's 1 day, Tuesday's another day, and oh yeah, Wednesday's a 3rd day. So he spent 3 days running laps. I'll go ahead and show that on the bottom of my number line. And I always start at 0. 0 days, 1 day, 2 days, and 3 days. You can see the days there. Now that I've got my days, or my time, how often it's happening, on my number line, I can start thinking about my action. Well, after 0 days, Elijah hasn't run any laps. If there haven't been any days, he hasn't run any laps. So after 0 days, Elijah's run 0 laps. But then the first day happens, and we know Elijah runs 5 laps every single day. So that means that the first day he runs 5 laps. I'll show that with a jump from 0 to the first day, a jump on my number line, and I'll add 5 that day because he ran 5 laps. So after 1 day, he's run 5 total laps. Then the second day happens, and again, Elijah runs 5 laps that day. So I'll show that with another jump. He ran 5 laps again. After 2 days of running, he had run 5 days, then he had run 5 laps, then he ran 5 more laps. I added 5 more. So after 2 days, Elijah has run 10 total laps. Then the third day happens because we know he ran for 3 days, Monday, Tuesday, and Wednesday. So I show another jump to show that he ran 5 laps again. He runs the same number of laps every single day. So I'm adding 5 each day. He had run 10 laps. Then he ran 5 more, so after 3 days, he's run 15 total laps. This is what our number line would look like that represents the problem. Elijah runs 5 laps around the track each day on Monday, Tuesday, and Wednesday. You can see that we've represented the time, or how often it happens, on the bottom, 3 days. You can see that we've shown that he repeatedly runs the same number of laps each day with our jumps and adding the same number, 5, each time. And you can see the total number of laps he's run after each day. 0 days, 1 day, 2 days, and 3 days. So really, on this number line, you can see the answer to the problem. After 3 days, that's all the days he ran, Elijah's run 15 laps. Now that you know about repeated addition problems and how to make a number line to represent them, let's go ahead and solve a repeated addition problem together. Just like with any other story problem, we'll use our problem-solving process to solve it. We'll start by reading and understanding the problem, thinking about what do we know and what are we trying to find out. We'll plan how we're going to solve it by determining the problem type and organizing the information in a number line, since this is repeated addition. Then we'll solve it by choosing an operation and solving, and of course we'll look back and check at the end to make sure our answer is reasonable. Let's go ahead and start by reading and understanding our problem. Here's the problem. Lenny read 10 pages of his book each night for 5 nights in a row. How many pages did he read in all? Well, I can see that one piece of information is that he read 10 pages of his book. Now, in a repeated addition problem, there's an action and there's a time or how often something happened. Well, if he's reading 10 pages of his book, that's an action. That's something he's doing. And he does it each night. It's our repeated action. The other piece of information in this problem is that he read 10 pages for 5 nights in a row. Well, that's how often he did it. He did it for 5 nights in a row. That's my time. It's how often he did it. The question I'm trying to figure out is how many pages he read in all. Now you know. Now it's time to go to step 2. We're going to determine the problem type, although today we know it's repeated addition because that's what we're solving, and we're going to organize our information. We're going to go ahead and start with our number line. And like we talked about earlier, we'll start specifically by thinking about what the action and the time, or how often it's happening, is. We talked about how the action is pages read, or he's reading pages. So that's the action, and we know that this is happening each night. So our time is nights. We're going to start by putting the time on this number line. How many nights did Lenny read for? Oh, that's right, he read for 5 nights. So I will start at 0 on my number line and show all 5 nights. Here you can see 0 nights, 1 night, 2 nights, 3 nights, 4 nights, and 5 nights. The story problem says he did it for 5 nights. So my number line goes from 0 nights to 5 nights. I want you to notice how I did my best to make the distance between each tick mark. That's what we call these lines on the number line. I did my best to make the distance between each tick mark the same. When we're making a number line, we always do our best to make the tick marks the same distance apart. Now that we've gone ahead and put our time, or how often it's happening, on our number line, we can start thinking about the action. We know that after 0 nights, he has read 0 pages. Of course, if he hasn't even started reading yet, it's been 0 nights, then he couldn't have read any pages. But then the first day happens, and we can see in the story problem, it tells us he reads 10 pages every night. So that first night, he's going to read 10 pages. I'll show that with a jump on my number line, and I'm adding 10 because he read 10 pages that night. He had read 0 pages, then he read 10 more, so after 1 night, Lenny has read 10 pages. Then the next night happens, and again, Lenny reads 10 pages. Remember, this is a repeated addition problem, so he's reading the same number of pages every night. We'll add 10 more pages again, and we'll show that with a jump on the number line. He had read 10 pages, then he read 10 more. 10 plus 10 is 20, so after 2 nights, Lenny has read 20 total pages. Then the third night happens, and again, Lenny reads 10 pages, because he reads 10 pages every single night. The action is the same each time, so we're adding 10 each time. I showed that with my jump, and he had read 20 pages, then he read 10 more on this third night, so after 3 nights, Lenny has read a total of 30 pages. Then another night happens. How many pages did Lenny read this fourth night? That's right, 10 again. It's 10 every time. In a repeated addition problem, the action is the same every time. So he's reading 10 more pages each night. He had read 30 pages, and then he just read 10 more. So after 4 nights, Lenny has read 40 total pages. Then the 5th night happens. How many pages did Lenny read the 5th night? That's right. The 5th night, Lenny read 10 pages again. He reads 10 pages every single night. The action stays the same each time. He had read 40 pages, then he read 10 more. So after 5 nights of reading, how many pages has Lenny read in all? Absolutely, Lenny has read 50 total pages. Look, third grade, we just made a number line that represents this repeated addition problem. Awesome job working this with me. Now that we've made our number line and we can see the repeated addition problem on it, each night he's reading 10 more pages, and the total number of pages increases each night, we're going to go ahead and show this on a grid. One of the pieces of information is that Lenny reads 10 pages each night. I'll show that on the horizontal axis or horizontal side. And the other piece of information is he did it for 5 nights in a row. So I'll show that on the vertical side of my grid. I'll go ahead and make my 10 by 5 rectangle. And here we can see an area model representation of this repeated addition problem. We know that if we counted every single square, it would tell us the total number of pages he read in all. Of course, we won't do that because we're third graders and we know how to multiply. I want you to ask yourself, if all of the squares are all of the pages Lenny read, what does just one square represent in this word problem? You're right. One square would represent one page. Now it's time for step 3 of our problem-solving process. We're going to choose an operation and solve the problem. Let's go ahead and think. How would we solve a repeated addition problem? Of course, we could add 10 plus 10 plus 10 plus 10 plus 10, but we're third graders, so we're not going to do that. Instead, we're going to multiply the number of we're going to multiply the repeated action times how many times it happened. We're going to go ahead and multiply 5 nights, how many times it happened, times 10 pages read per night, which will equal n, the total number of pages read. Thankfully, we know 5 times 10, so we know what n equals. In this problem, n equals 50. Now I want you to think. The problem is, how many pages did he read in all? What would be a great answer to that problem? Oh yes, we'll make sure to include, of course, our number, 50, and we'll also make sure to include pages that he read, because that's what this 50 is. It's 50 pages he read. A great third grade answer for this problem would be, Lenny read 50 pages in all. We're ready for our final step. We'll look back and check. The numbers that we decided to use to solve this problem were 10 pages read and 5 nights. Were 10 and 5 the numbers from the story problem? They were. We multiplied to find the answer. That's correct. We multiplied to solve repeated addition problems. And we decided that 5 times 10 equaled 50. That's correct as well. Finally, let's look at our answer. Did we restate the question? How many pages did he read in all? We did. Did we include the correct answer, 50? We did. Awesome, third grade. It looks like we have written an excellent third grade answer. Third grade, thank you for learning about repeated addition problems with me today. We'll learn more about repeated addition tomorrow.